So we're here at just underneath the Severn Bridge, looking for dinosaurs, or, biblically, dragons. We're here with Creation Research UK, as you can see. There's a whole group of people with us today, and we're just looking around on the beach, finding fossils. We've already found some ichthyosaur bones, and mostly shells. But it's a fascinating day. We're having great fun just looking for dragons and shells and fossils and showing God's creation.
It was fairly easy. Here's a slightly trickier question. How did you know that it was a stone?
Hard.
What was that?
It's hard.
Because it's hard. That is absolutely the right answer. I'm going to be really mean. I'm not going to help you find fossils to begin with. Because what I want you to see is, once you learn how to find fossils and once you learn how to recognise fossils, you will start to see them everywhere.
So as you can see behind me, these are the cliffs where all these stones and fossils come from. And perhaps you can just see now people are starting to look around. We'll just be having a break for lunch before we start going to look for more fossils. You can see the layers, the various layers as you go up. So you've got Triassic and you've got Jurassic layers laid down in the flood.
That's just a little bit of iron. That's bone there.
Okay.
This is the surface that is touching the red rock. Look at this one here. So basically, the rock is sitting that way round, right?
Yeah.
The layers of the limestone are going up, and this is touching the surface of the red rock. It's being deposited during the flood, very quickly being laid down. The other current is on the top. As the rock is being compressed, the red rock, you're going to get gas bubbles that come out, you're going to get water that's draining, and you're going to get little gutters. So sometimes you see complete, almost like little stream gutters kind of running through. That's going to make holes and all sorts in the actual red rock.
Yeah.
As the harder rock comes and settles on top of it, any of those little gas bubbles, any of those little holes are going to get infilled and covered up, particularly by harder solutions. So most of these are iron solutions that have settled into the little gutter trails that are on the surface.
Oh, right.
And that's why you find a concentration of bone material here, because as the tides are washing over,
because you've got that piece, there's a small piece there.
There's a nice. Yeah, so you're gonna get bits of rolled bones and stuff washed into place, and so on and so forth. That is a big bit of poo.
I found some poo!
So what I would do.
So point to the poo, just that bit there.
Amazing, right? Precious.
Well, let's work through it a little bit further, shall we? Because these rocks are supposed to have formed very, very slowly, and in fact the bottommost rocks are supposed to have formed in a desert, and the desert is supposed to have become flooded and formed the rocks that are up on the top. And yes, there is lots of good evidence of flooding, mainly the fact that it's all marine sediments that are up there, and right at the top you can sometimes find plant material. Accumulation that you see here tells you that this is not just a shallow marine environment, it's actually a flood deposit. It's a deposit that has swept in and brought a whole mixture of creatures and plants and animals and buried them together very, very quickly. But what are the crystals that we've been finding? What are they called? Gypsum. And the Romans liked it because they used it for their plaster. Well, crystals tell you that they once weren't crystals. Crystals tell you that they were once a solution. Of course, the solution is wet. And that solution has evaporated into what we have basically got as crystals today. And in fact, if you have a look, you can see where all the gaps and all the layers, where all the solution has managed to filter its way down and fill up all these gaps and gullies, and it's produced all the lovely gypsum crystals that we see today. Now, the fact that this was supposed to be a desert and the fact that we've actually got gypsum crystals in this abundance here gives you a very good indication that they're not actually a desert environment at all. The fact that it's still here as a cliff and it's not in a desert tells you it hasn't ever become a desert, and in fact it never was a desert because it's full of these gypsum crystals which had to have formed underwater. In other words, we're not looking at a drowned desert, we're looking at a water deposit on top of another water deposit. Two water deposits together. But then that shouldn't really surprise us because the Bible talks about a global flood that covered the entire world. And if there's one thing you know about huge volumes of water in floods, it's that you can have lots of different currents. And those currents can be travelling in different directions. And those different directional currents can be carrying different types of sediment based on how fast they are going and how big they actually are. I mean, Hunt for Red October, you go down underneath a current and the sonar can't penetrate down and find the submarine. Right? We've known about these kind of ways that rock layers interact and sediments form for a very long while. What most people are unwilling to do in the geological world is actually apply it in a way that fits a global flood scenario. That's why so much of them tend to be ignored in terms of looking at local flooding. I mean, most geologists haven't got a problem with a flood anymore, but it must be a local one. Well, that doesn't really make sense because what's the rock layer right at the top? What did we say it was called?
Jurassic.
The Jurassic rocks. What are the Jurassic rocks named after? The rocks in the Jura Mountains, which means that if you have the same Jurassic rocks here in the UK as you do in the Jura Mountains, with the same fossils in them, with the same dinosaur and dragon fossils for sure, with the same shells, with the same rock type, from here to the Jura Mountains, how big was that flood? Well, it went at least from here to the Jura Mountains. Of course, the problem is that you can also dig up Jurassic sediments over in the United States. That's a pretty big flood. And over in Australia, we have got an outdoor museum called Jurassic Ark, and it's called Jurassic Ark because it sits on, you guessed it, Jurassic rocks. In other words, the Jurassic deposits are a global deposit. They go all over the world. They are very, very large. One of the things that is almost never done in academia is the chance to step back and actually get the big picture. The reality is these rocks go all over the world and they all clearly have got drowned creatures in them. They're all clearly the result of a flood deposit. The same can be done for the Triassic. The same can be done for the Cretaceous. The same can be done for the Carboniferous. In fact, the Carboniferous is quite interesting because there's a little bit of politics here for you. You see, the British named the Carboniferous rocks Carboniferous. Why do you think we call them Carboniferous? What are they full of? Carbon, yeah. They're full of trees for sure, yeah. But all the trees have turned to coal. You see, the Carboniferous are called Carboniferous because it's full of carbon. And carbon was quite important to us Brits because we had a revolution. It was an industrial revolution and we needed an awful lot of carbon in the form of coal. The Americans, being the rebellious sort that they are, did not go with the British names. They take the Carboniferous and still do it to this day. They split it in two and they call them the Pennsylvanian and the Mississippian. No prizes as to guessing what those rock types are named after. But the reality is they're exactly the same as the Carboniferous, and you know this because you can trace the Pennsylvanian and Mississippian rocks from down in Florida all the way up through Alabama, up through Tennessee, up to Pennsylvania where they're named after, and up into Canada. And the Canadians are still loyal to us Brits, and so they also call them the Carboniferous, even though they're exactly the same rock type. You see, it was Professor Derek Ager that first pointed out that these rock layers go across the world. He was the professor of geology at Swansea University, not too far in that direction. And he recognised that rocks like this go across the world, and there is no explanation for them if you want to argue for a slow and gradual deposit. In fact, a little bit further down the road down here, if you carry on down the Welsh coast, you get to a place called Ogmore. Now, the standard assumption is that rock layers form very slowly using modern-day processes, slowly, bit by bit by bit. But you can start at Ogmore, start walking down towards Southern Down, and you can find one remarkable thing. It is all the same deposit, and all the fossils are pointing in the same way. And so Professor Derek Ager coined it the Tuesday afternoon deposit, because he said, this is so big, but it must have happened on a Tuesday afternoon, given the speed that we can see that this water must have moved in order to deposit this volume of sediment. And I actually agree with him. Now, he never became a Christian or a creationist. In fact, he actually wrote in one of his books that he wanted creationists not to use his work. But I'm sorry, Professor Ager, your point is so good. It really is a problem if you want to apply the slow, gradual, uniformitarian belief system into the world around us. It simply doesn't work, whereas the rock layers being formed in a massive flood that once covered the world really does fit the evidence so much better. Of course, you might then go on to ask the question, all right, if the evidence of Noah's flood is so clear, and it can be seen so far around the world, why don't people believe it? Surely the scientists can't be that silly and stupid. Surely they must be able to see the evidence of a global flood. Well, there's a few sort of answers to that question. Unfortunately, none of them paint us in very good light. It starts with when the Bible says the heart of man is desperately wicked. Now, we don't like to think of ourselves as desperately wicked, but then you know what else the Bible says? God is not a man that he should lie. If God is not a man that he should lie and I am a man, what does that mean I do? I lie. If I lie, then you can call me a liar, and the Bible says that if I lie, I've broken one of God's rules, which means I'm deserving of death. Now, before you all start pointing fingers and laughing, that includes all of you, by the way. You see, the Bible paints us as sinners, sinners that want to reject the Creator, sinners that want to reject any form of accountability. Now, think about it. If there really was a global flood, what caused the flood? Any ideas? What caused the global flood described in Genesis? Sin? No, it wasn't sin. God did. You see, it was God's judgment on sin, but there's a very important distinction there. It wasn't our sin that brought the flood on. We didn't somehow magically our sin causing a global flood. It was God's divine judgment on mankind because of our sin. In other words, follow the logic through, folks. If there really was a global flood, it means that not only is there a God, it means there's a God who can judge, a God who has the right to judge, a God who's judged in the past, and a God who's probably, he's promised us he's going to judge in the future, and this God probably has a few rules we ought to be following. Do you see why some people might not like the idea of a global flood? Couple that with a couple of other things.